A warm welcome to everyone. In this video, we are going to see how to solve assignment problem by Hungarian method. I am Mr. V. Ratanakumar, Assistant Professor and Head, Department of Mathematics, PPG College of Arts and Science, Coimbatore. Hungarian method is widely used method to solve assignment problem. In assignment problem, there are two types in minimizing the cost. First one is balanced assignment problem. Second one is unbalanced assignment problem. Balanced assignment problem. The number of rows equal to the number of columns, then the problem is balanced assignment problem. The number of rows less than or greater than the number of columns, then the problem is unbalanced assignment problem. Let's see the problem. Consider a problem of assigning 4 clerks to 4 tasks. The time required to complete the tasks are given below. Clerk 2 cannot be assigned to task A and clerk 3 cannot be assigned to task B. Find the optimum assignment schedules. Solution. Since clerk 2 cannot be assigned to task A and clerk 3 to task 3, allot infinity to these places. Then the assignment becomes like this. So after the allocation of infinity, we will move on to step 1. Choose the least element in each row and subtract it from all the elements of that row. Then the assignment becomes, this is table A. From table A, we have to construct table B. In the first row, 4 is the minimum. So we have to subtract 4 from all the entries of that row. Then the entries are 0, 3, 1, 2. The second row, again 4 is the minimum. Then the entries are infinity, 4, 3, 0. In the third row, 3 is the minimum. Then the entries are 0, infinity, 2, 0. In the fourth row, 2 is the minimum. Then the entries are 4, 4, 2, 0. So after the completion of step 1, we will move on to step 2. Choose the least element in each column and subtract it from all the elements of that column. The assignment becomes, so this is table B. From table B, we have to construct table C. In the first column, 0 is the minimum, so keep the values remain same. So 0, infinity, 0, 4. In the second column, 3 is the minimum, then the entries are 0, 1, infinity, 1. In the third column, 1 is the minimum, then the entries are 0, 2, 1, 1. In the fourth column, 0 is the minimum, then the values are remain same. So we will move on to step 3, row scanning. Starting from the first row, if there are only 1 0 in the row, mark a square around the 0 entry and draw a vertical line passing through that 0. Otherwise, skip that row. So consider table C. In the first row, there are 3 zeros, so we have to skip that row. In the second row, there is only 1 0. Mark a square around it and draw a vertical line passing through the 0. In the third row, there is only 1 0. So mark a square around that 0 and draw a vertical line passing through the 0. In the fourth row, there is no zeros. So we will move on to next step. After the row scanning, check whether all the zeros are covered with the line. If yes, go to step 7, otherwise do column scanning. So in the table C, there are 2 zeros which is not covered by any line. So we will move on to the column scanning. Column scanning. Starting from the first column, there are only 1 0 in the column. Mark a square around the 0 entry and draw a horizontal line passing through that 0. Otherwise, skip that column. Here, the first column, there is no 0. In the second column, there is only 1 0. Mark a square around that 0 and draw a horizontal line passing through that 0. In the next column, there is no 0. Then we will move on to the next step. Step 6. After the column scanning, check whether the number of square marked is equal to the number of rows of the matrix. If yes, the optimum solution is reached. Otherwise, go to the next step. Here there are only 3 zeros, but the number of column is 4. So that we will move on to the next step. Identify the minimum value from the undeleted cell, then add that minimum value at the intersection point of the present matrix. From undeleted cell, 1 is the minimum value. Add this minimum value at the intersection point. 0 plus 1 equal to 1, 2 plus 1 equal to 3. Then the next step, subtract that minimum value from all the points which is not striked by the line. Keep all the other entries remain same. So subtract 1 from all the unmarked entries. So 1 minus 1 equal to 0, 2 minus 1 equal to 1, 1 minus 1 equal to 0, 1 minus 1 equal to 0, 1 minus 1 equal to 0. After this, we will move on to the next step. Do again step 3, 4, 5 and 6. This row scanning and column scanning process. The first row, there are 2 0, so that we will move on to the next row. The second row, there are 2 0, so skip that row. The third row, there are 3 0. In the fourth row, there are 3 zeros, so we go to the column scanning. The first column, there is only 1 0. Mark a square around it and draw a horizontal line passing through that 0. In the second column, there are 3 zeros, but randomly we select the first 0 and draw a horizontal line passing through it. In the third column, there is only 1 0. So mark a square around it and draw a horizontal line passing through the 0. In the fourth column, there is only 1 0. So mark a square around it. Then the number of square marked is equal to the number of rows of the matrix. Hence, the optimum solution is reached. The optimum solution is clerk 1 is assigned to task B. The time is 7 hours. Clerk 2 assigned to task D. The traveling time is 4. Clerk 3 assigned to task A. The time is 3. The clerk 4 assigned to task C. Time is 4. The total minimum time is 18. Thanks for watching.